last semester's test had a bunch of problems. Now, the way the grading works is you get 2 points for a correct answer and you lose half a point for a wrong answer. So you want to do your best to guess, but it's really in your best interest only if you can eliminate a couple of these. Then it's a good idea to guess. If you can't eliminate a couple of these, guessing's not a good strategy. Now, a lot of these have some really elegant solutions, and Dan is good at the elegant solutions. I'm good at the sludgehammer solutions. I'm like, okay, I just want the answer. So let's work with this. This first problem defines an operation with a hashtag, and I'm going to show you a couple tricks on your graphing calculator that can make some of this stuff kind of easier, actually a lot easier. So let's take a look here. It's X hashtag Y is this operation here. Let me kind of zoom in. Of course, you've got that on your sheets. And they asked us to calculate 2 hashtag 5 hashtag 2. Now, of course, that 5 hashtag 2 is in parentheses, so that has to be done first, right? That's your order of operations. So if we're doing 5 hashtag 2, then 5 is the X. So let's take our calculators out and store 5 in X. So you did press the 5 key and then the store key and store that in X. That's right here next to the alpha key. Great. We also need to store 2 in for Y. So again, go down to the bottom row of your calculator, or second to the bottom row, hit the store key. Now the problem is, well, where's Y? If you look right above the 1, above and to the right, that's where Y is. To get to that key, I need to hit the green alpha key. So I'll hit alpha and then a 1. Oops. Actually, somehow or another, I got a 2 there. There we go. So 2, store in Y. And now what I'm going to do is I'm going to let my calculator do all the work for me of X, Y squared, and all that other stuff defined by this operation right here. Now let me just pause, make sure, has everyone got X and Y stored appropriately? Okay. Now, here's a little trick that's going to make our life somewhat easier. We're going to type in this fraction pretty much exactly the way it's typed in there. Now, how do you do that? If you hit the alpha key, then the Y equals key, so alpha and Y equals, it gives you a bunch of different options as to how to do a fraction. So I want the first one, which is just going to allow me to do a fraction just like I have here. So type the number 1, and let's type in this expression. So, okay, that's going to be an X and then a Y squared. So you hit the alpha 1 and then the squared key plus and then Y X squared. So alpha 1 again and then X squared. Now cursor down into the denominator and we're going to type in 5 plus X squared Y squared, X squared, and then alpha 1 again, squared. And then you can cursor over to the right. But do we all have that expression typed in? Yeah, go ahead. Which one? Oh. Oh, alpha. Yeah. Yeah. Alpha linked? Really? Wait, don't right now.
I won't. Really? Does it work?
No.
It doesn't work for us.
Yeah. All right. All right. Well, anyways, let's no, we'll play with that one a little bit. If we press enter, then we get this. That's that's what was it? 5 hashtag 2. So we got the first part of it. We got 2 hashtag 5 hashtag 2, and 2 hashtag 5 hashtag 2. That can be replaced with 2 hashtag 2/3. So we've already done all the hard work in this. The thing to realize is that we've got a new x and a new y. This is your x and this is your y. So I got to go back and store in some new variables. I got to store in 2/3 for y and 2 for x. So let's do that. 2 store in x, and then 2/3, 2 divided by 3, store in y. Oops. I'd have to see exactly what you could go back and edit this up here. But I've got my variables redefined now. And now I got to put these things back into my equation. But the good news is I've already got that equation typed in, right? So just cursor up until you're on that equation. If you press enter, it brings it down. Press enter again. There you go. There's your answer. So pretty cool. Just do it mechanically. So that one gave us 32/61, and that's your answer right there. Nailed it. So how are we looking on that first one? Okay. There's kind of a follow-up to that one, a part B here. And it asks you whether or not this operation is commutative and associative. Let's start with the commutative part first. Commutative means that if you do like 3 plus 4 or 4 plus 3, it doesn't matter which order you do the operations. So the question is this operation commutative? If I put in 5-2 or 2-5, am I going to get the same thing? Well, let's take a look here. If I interchanged x and y, well, let's see, I've got xy squared and yx squared. Essentially, those would be the same if I interchanged x and y. And down here, x squared, y squared, well, it doesn't matter what you square in what order, you're still going to get the same thing. So it would be commutative. What about associative? If the operation is associative, then associative would say I should be able to move the parentheses. So I should be able to say, all right, that's the same as 2 hashtag 5 hashtag 2. But it wouldn't matter what order I did the parentheses. So having defined this, it wouldn't take too much work to go back and double check that it's not associative. That is, if you moved the parentheses and did it in a different order, you would get a different answer. So that, and you can show that to yourself just by plugging in the numbers for this and calculating it out. I'm not going to take the time to do it, but if it is commutative and not associative, then B is the correct answer. So, so the first two, again, aren't too bad. Dan, I think were you going to do number 3? Okay. No. I think we divided things up that you were going to do number 3. So here you go. Thank you.
Okay. Better. More comfortable. Okay, so number 3, besides solving it, can I have a pen, please? Thank you. So number 3, besides solving it, I want to mention something about these kind of problems. You read number 3, if you take, let's read it out loud. A 40-yard by a 30-yard garden subdivided into 1,200 squares, each with side length 1 yard. So you have a sort of a picture right here. And then a post was placed at each corner of each square. blah, 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 blah. So they put one post on each one of these big dots right here. And every little site is of length 1. That's what they tell you. And then they say, let P be the number of posts used, so how many big dots you have. And let F be the number of fence sections used, so the number of sites that you have. And this looks like a fairly complicated problem, especially when you realize that this is a 40 by 30 yard. So you would have to make this grid 40 by 30 and then start counting. Well, can you do that? Yeah, sure. You can take the time to do a 40 by 30 and start counting. Use some basic facts of multiplication to come up with the answer, but probably it's going to take way too much time. Think that you have 1 hour to finish the whole test. So one general strategy that you can apply in this kind of problems is make the problem way easier. Simplify the problem. Get yourself a very small grid and try to solve the problem using the small grid. And once you see how the small grid works, that will tell you exactly how the big grid works. So you can generalize to the big problem using a very simple example. So let me show you how I handle that. What I did is I went as simple as I could. Of course, don't go too simple. If you do a grid that is 1 by 1, then you have 1 dot, no sides. That doesn't tell you anything. But what I decided to do here, can I try this one? Yeah? Okay. So this is what I did. I thought, okay, let me do the simplest example that I can think of that is not too simple. So I did a 2 by 3. So, and I thought, okay, I have a 2 by 3 grid. And I want to count first how many posts I'm going to have. So those are the big dots at the intersection. Oh, I can even draw them. That doesn't take long. Cha, 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 and cha. You don't have to say cha when you draw them. That's okay. And then you tell me how many big dots do we have? 12. And how do you count them quickly? Yeah, so 4 times 3, correct? So we have P, in this case, the number of posts is 12, and we get that out of 4 times 3. Let's say, instead of 4 times 3, let me say 3 times 4. And what do we notice already? Look at the size of the grid. Look at the size of the grid, and look at the number of posts. If this was 8, what would that be? If we had instead of a 2 by 3 grid, we had a, I don't know, let's say an 8 by 10 grid. What do you think that the number of posts would be based on this? If this is a 2 and this is a 3, the way we count the posts was 3 times 4. We add 1 to each one of the dimensions. So this would be a 9 times 11 for the number of posts, correct? Does that make sense? Okay, so if we want to calculate the number of posts for our situation, our grid is, what do they say? 40 by 30. Okay. So the number of posts is going to be 41 by 31, which happens to be, you have a calculator with you, 1,271. Okay, I already have P. Neat. Now let's go for the other part. Okay, so let's count how many sides I have. So that's what we call F, the number of fences. So let's figure this out. Let's count first, for example, the number of horizontal sides that we have. We have 1, 2, 3. And how many copies of that I have? So if I look at the horizontal sides, I have this side right here, I have this side right here, and I have this side right here. Huh? That's 3 sides, correct? How many copies of these 3 sides do I have? I have 3 copies of those 3 sides, correct? This is my first copy, this is my second copy, this is my third copy. Does that make sense? Okay, something happened here. Did I? Okay, there we go. So we have 3 times 3 for the horizontal sides. Now let's count the vertical. So plus. For the vertical, I have 1 and 2 right here. How many copies of these 2 sides do I have? 4. So I'll have 2 times 4. So that's 9 plus 8, which is 17. Okay, that's for the 2 by 3. Now let's try to figure out what happens with our B grid. So F. All right, let's think about how I did the horizontal. For the horizontal, I got the number of columns that I have, which was 30. And I'm doing this different than what I have in my notes, so I hope it works. I did 30, and I multiplied by the number of rows that I had plus 1, correct? So it was 2 rows plus 1, so that would be 40 plus 1. And for the number of horizontals, I got the 40, and I multiply by the number of rows plus 1, which was 30 plus 1. And if I come up with the answer of this is 2,470. And now we can actually solve the problem. If I add the P and the F, that is what the problem is asking me to find P plus F, right here. I add these 2 quantities, and what I get is 3,741. Does that make sense? Yep. So what's the idea here? Because, of course, you're not going to get exactly the same problem. The general strategy that I want to communicate you is big, complicated picture where it's hard to count something, make a small picture where you can come up with the pattern that the counting follows, and then try to apply it to the general case. Make sense? Thank you.
Yeah. Now, we're not going to try and do all of them here today, but maybe Dan will publish his solutions. We are going to go through some that we think are quite doable. And one of the themes that you're going to see quite often in these tests is something that involves the current year. So in this case, it's problem number 8, 2118 or 2018. So the question is, how many distinct solutions A, B, and C, where A, B, and C are all positive integers? And of course, that means that these are values of 1, 2, 3, 4, 5, 6, etc. You can't have any fractions, can't have any decimals or negative numbers. You can't even have 0. How many are there such that A to the 6th plus B to the 2nd plus C cubed equals 2018? Well, when I looked at this originally, I'm like, all right, well, you're going to run into a problem with the A to the 6th term. When you take something to the 6th power, it gets really big really fast. So you can experiment. 3 to the 6th power is 729. 4 to the 6th power is already too big. It's 4,096. So the values for C are kind of limited. That really limits you in this problem. So C, at most, could be 1, 2, or 3. That's the most it could be. Now, let's assume that C equals 1 in this equation, so that I have 1 to the 6th plus B squared plus C cubed equals 2018. What I want to do is I want to solve this for one of the remaining 2 unknowns. So I'm going to solve for B by moving everything to the other side. So it's going to be B squared equals 2018 minus 1 to the 6th, and of course I know I can do that as 2017. I'm just going to leave it here, minus C cubed, and then I'll take the square root on both sides. So 2018 minus 1 to the 6 minus c cubed. What I want to find is integer solutions for this. And I can do the same thing for when c is 2 and when c is 3. So let me write down 3 expressions. And if you wanted to simplify these, if you just want to write in 2017, that's fine. Nothing wrong there. But let me just write in the general case for these other two. 2018 minus 2 to the 6 minus c cubed. And last one, last column of c is 3, 2018 minus 3 to the 6 minus c cubed. Great. So you've got all 3 possible solutions depending on the value of c, and you're looking for values of b that are nice integers. Well, let's take out our calculator and just let our calculator grind through this, because we can get this really quickly. Now, if you've had me in class before, and you remember that I said keep your table set up at independent ask, well, I'm going to change that. I know I said keep it there for the rest of your life, but we're going to make a change just this time. And we want table start. Table start can be 0, and delta table will be 1. So your setup should be like this. And let's plug in the different numbers or the different expressions for us for the y equals. So, somebody messed with this. Hang on. Apps. Let's see. Equals. Quit. All right. Let's see. Yeah, there we go. All right. So let's put in those expressions. It would be the square root of 2018 minus 1 minus. Now I'm just going to use x to the third. So x raised to the third. And I'm going to put in 2 more expressions like that. I'm going to put in the same expression except minus 2 to the 6, and the same expression except minus 3 to the 6. So there, 2018 minus 2 to the 6 minus x cubed. And wherever I see nice integer solutions in the table, I just want to count that. Minus. Now, you can do 2 to the 2018 minus, let's see, 729 would be what? 1289. So you can just type in 1289 minus x cubed. I'm doing it this way just to be clear about what I've got where. Minus x cubed. So when you get all these things in, we're going to do a table and just look for the integer solutions. So has everyone got these equations typed in one form or another, whatever form you kind of like? So once you get that table set in, you hit the second key, then the graph key, and you just scroll down and you start looking for the integer solutions. Does anyone see an integer solution here? Yeah, right here, 35. So it would be when C is 3 and B is 5 and B is 4 and then 35. But you know what? We don't even need to really make sense out of, well, what numbers they are as far as a solution. That's a solution. Here's another solution. So that's 2. There's a third solution. And you start going down too far, and guess what happens? You start getting errors. That's because your numbers are too big. So all you had to do was scroll all the way down to 13, and I see 1, 2, 3, 4 solutions. And that's it. Done. You're absolutely done with that problem. You look on the sheet, and bam, 4 is one of your possibilities. So kind of a nice use of the table function there. I mean, I'm sure there's a lot of beautiful ways to do this in other ways. But remember, you get points for getting them right. Doesn't have to be pretty. Ronnie? No. So this is it's just a multiple choice test. So you want to get the answers as fast and as dirty as you can, and that's a good way to get a quick and dirty answer. So now I have to turn the mic over.
No, wait.
Go ahead.
Because I think it's getting late. I'll do that one if we have time. I think that a very, very good example of showing you the difference between getting the solution and get it done and solving it exactly is problem number 12, which is actually pretty short.
Okay.
So I would ask Jeff if he can show you how to solve this problem with the calculator, and then I'll show you how to solve the problem without the calculator.
Okay. So problem number 12. Again, you're just looking for the solution to an equation, and as long as your equation just has one variable, you can make this something really, really quick. In fact, I had a question on my exam today, and it was solve, I think it was 4x plus 5 equals 7. That was the equation that they got. And if my students were savvy enough, what they could do is move this to the other side. 4x plus 5 minus 7 equals 0. And realize that if I define an equation like this, y equals this is going to cross the x-axis when y equals 0. So basically, I'm looking for the y-intercept or the x-intercepts of this graph is what I'd be doing. And the solution in this case was when x was equal to 11. How does that apply to us here? Well, this is my equation. Log base 8 of x squared, log base 8 of x squared times log base x of 8 squared equals 1. I'm going to do the same thing with this that I did with the equation that my students faced earlier today. I'm going to move this over here and write this new function, log base 8 of x squared times log base x of 8 squared minus 1. And I want to see where this crosses the x-axis. And that's where I'm going to have a solution. The only tricky part you're going to face is dealing with the log of a particular base, like this. Let's see if we can't handle that. So let's go back to our equation editor. So y equals, let's clear out all the stuff from the last problem. So clear, and clear. And then we're going to type in this equation. So zoom out a little bit, not too much. There we go. Start with a left parenthesis, and I need to do log base 8. Well, your calculator can do this, and it'll actually type it in for you. You just got to know where to go. And there's a couple places. The one that I know the best is if you hit the alpha key and then I think the window key. Now, there's another way to get this. I can't remember where it is off the top of my head, but it gives you log of a particular base. So log base what? Base 8 of x, and then hit the squared key, and then you got to exit out of this and use a right parenthesis, because that right parenthesis closes off your log, and that now is this first log term right here. So are we okay on that? You got log base 8 of x squared, that part of it. If you're a little bit behind, let us know. We can help out. We're good on that one? Okay. Then we'll type in log base x of 8 quantity squared. So again, let's go back to that window, alpha, and then window. Fifth option down. This time I want to put an x here. Log base x of 8. And then another right parenthesis, squared, minus 1. So that's what your expression should look like. So we're all together on this one. If you need some help, let us know. All right, it says, let's see. It says the solution to the equation lies in which of these intervals? So we've got intervals that go from 0 to 1, 1 to 10, 10 to 50, up to 100 and beyond. So what I'm going to do is I'm going to graph this. I'm going to set my window, let's see, window from 0 to, let's do 125 on the x-axis. And if you're not sure what to do for the y-axis, you know, you can make your calculator figure that out for you. So let's just take a guess at it. Let's go from negative 10 to 10 on the x-axis, or on the y-axis, I should say. And now I'll hit the graph key. Oh, wow. Didn't realize. All right. No, I wasn't. I'm not sure.
Maybe the app, because you're running that app.
Yeah, there's some app running in the background.
You press
Apps,
and go to that
inequals,
and now say
quit.
And now try again.
It's still there. Still there. That is kind of cool, though. But you should see a graph that crosses the x-axis some places, right? You guys seeing that on yours?
Do you guys see it? Is it in your calculator?
Yeah. Let's see here. Now, the question is, where does it cross the x-axis? Well, what we can do is try and zoom in a little bit. Since our graph is too tall, let's adjust our window. Let's go between, say, negative 1 and 1. And I'll also do one more thing to my window, and that is put in x scale of, say, 25. Maybe I'll do 10. There we go. Okay, so the window that I used was between 0 and 125 on the x-axis, scale of 10, and between negative 1 and 1 on the y-axis. So the question is, where does this cross the x-axis? Right? I mean, that's really what we got to know. You can kind of estimate it, 1, 2, 3, 4, 5, etc. But let me remind you of your calculator's capabilities. Each one of those tick marks, I think, is 10. So each one of these tick marks is 10. So 10, 20, 30, 40, 50, 60. So it's more than 50. And I think that's really all we need to know for our answer, right? So between 50 and 100? Okay, so that's one way to work on it. Now Dan's got a much more elegant and mathematical solution, but this one is a nice brute force approach. It can get you the answer pretty fast. Blunt trauma.
Think about this, about what Jeff did, is that you didn't really have to do any computation. All the work was about typing it. Huh? Of course, you need to know what you need to know what the log key is, but now you know. Now, if you know a little bit about properties of logarithms, then you can actually come up with the solution in a very quick way, actually faster than what we did with the calculator. Because it takes a while to type all this stuff. So let me show you. The problem with this is, number one, you need to know your properties of logarithms. If not, you're going to be in trouble. And number two, you need to think of it. If you don't think of it right away, then yeah, it may take a while. So I'm just going to solve the equation algebraically. The equation says the logarithm in base 8 of x, everything squared, times the logarithm in base x of 8
Nope, I already messed up. This square is right here. Yeah. A square equals 1. Correct? That's what my problem says. All right. So the first thing that I did is to say, okay, I'm going to apply one of the properties of the logarithms that says that if I have an exponent in the argument of the log, the exponent can come outside multiplying the log. So 2 log in base 8 of x. And then the logarithm in base x of 8 quantity square. That means the log in base x of 8 times the log in base x of 8. Something square means something times itself. Do you guys agree? Like 5 squared is 5 times 5. Log in base x 8 squared is log in base x 8 times log in base x 8. Okay, now the problem to solve this that you have if you want to solve this equation algebraically is that not all of your logarithms are in the same base. So what you do is you use the base of the change of base formula, correct? And the change of base formula tells you that the log in base 8 of x can be expressed as the natural log of x over the natural log of 8. Essentially, the change of base formula tells you that any logarithm, no matter the base, so let me give you an example here. Let's say a base. Tell me a number. 3. And let's put some expression here, or number, 9. I can express this always as a division of natural logs. Natural log of 9 on top, natural log of 3 on top. These two happen to be the same. That's what the change of base formula tells you. So that's what I did right here. Natural log of my argument on top, natural log of the base on the bottom. And I'm going to apply the same formula to the log in base x of 8. According to the formula, can you tell me what should I write in the numerator? Natural log 8. And in the bottom? Natural log x. And of course, this is the same thing. So natural log 8 over natural log x equals 1. All right, now there's a super nice simplification right here, correct? This 1 dies with this 1. This 1 dies with this 1. So I'm left with 2 natural log of 8 over natural log of x equals 1. Let's move the paper. All right, so now we want to solve for x. So bring the natural x to the other side. 2 natural log of 8 equals natural log of x. And now apply that property that I applied for the exponents backwards. I have a number here multiplying the log. I can put it in the argument as a square. Natural log of 8 squared equals natural log of x, which tells me that natural log of 64 equals natural log of x. If natural log of 64 is natural log of x, what is x? X is 64. So we got our exact solution, which of course is between 50 and 100, as Jeff told us. So pretty nice, straightforward solution if you're familiar with those properties of logarithms. So Jeff just found the solution right here. If we zoom, x equals 64. So.
Positive to negative, then it's passed through the x-axis. So yeah, it's a clever way to do it too. Yeah. All right.
Okay.
I think we're kind of running a little bit longer than we expected.
Yes.
So we will send out a link to register. You have to register for the Student Math League. We'll send out a link to you so that you can get registered. The test will be a week from today. What's that?
Is that Bitly?
Yeah, it's usually a Bitly link. I haven't looked at it yet, but we'll look at it.
Yeah, it is a Bitly. Yeah.
It's a Bitly.
Yeah.
All right. Exactly. Thank you so much.